Hi and welcome to WDS 2026, an international defense exhibition in Riyadh, Saudi Arabia. Today we will focus to one of the most important defense companies in US, General Atomics, who present its full range of unmanned aerial system, including the MQ-9B SkyGuardian and SeaGuardian, but also they present for the first time a full-scale model of the Gambit, the next generation of unmanned fighter aircraft. At World Defense Show 2026, General Atomics, one of the most important US defense company, unveils for the first time a full-scale model of the Gambit. This is the next generation of unmanned fighter aircraft. Today, many air forces from all over the world try to find new solutions to conduct many combat missions using manned and unmanned fighter aircraft. In this case, the pilot can control his own aircraft, but can control also up to 2 unmanned aircraft to conduct combat operation. Here you can see a full-scale model of the Gambit. This is the next generation of unmanned fighter aircraft, fully designed and developed by General Atomics. But what is very interesting, the Gambit is used to create different versions of the Gambit to operate in different types of mission. In this case, you can see that there is Gambit 1, Gambit 2, Gambit 3, Gambit 4, Gambit 5 and Gambit 6. All these versions are tailored to perform different types of mission. There is also the Gambit 5, which has been designed to be used on the aircraft carrier.
General Atomics aeronautical systems, long associated with unmanned aviation through aircraft such as Predator and Reaper, is presenting Gambit as a major step toward high-end air combat. Rather than producing a single unmanned platform, the company has built a scalable family organized around a shared foundation known as the Gambit core. This baseline includes landing gear, avionics, structural architecture, and mission-agnostic subsystems. Industry officials estimate that the common core represents about 70% of the aircraft's cost across variants, an approach intended to create economies of scale, ease sustainment, and shorten the path toward new mission packages. Because the foundation remains constant, individual versions can be reshaped through changes to propulsion, fuselage design, wings, and onboard equipment without restarting development from scratch. The outcome is a set of aircraft suited to very different tasks, but designed to operate together and connect directly with 4th, 5th, and future 6th generation fighters inside one networked force. The intelligence, surveillance, and reconnaissance model, often labeled Gambit 1, emphasizes endurance at the edge of contested airspace. By focusing on aerodynamic efficiency and fuel-conscious propulsion, it is meant to maintain continuous early warning, detect targets, and build battlespace awareness while keeping pilots away from prolonged exposure. Gambit 2 moves toward air-to-air warfare. Range on station is shorter than in the reconnaissance version, but the aircraft can carry missiles, effectively stretching the reach of crewed fighters. In practice, it functions as a forward screen, adding autonomous shooters and complicating hostile planning without putting aviators in immediate jeopardy. Preparation for conflict is the mission of Gambit 3. Configured as a trainer and aggressor platform, it is designed to mimic advanced opponents, including integrated air defenses and modern fighters. Using unmanned systems for this role allows air forces to conduct demanding scenarios more often, control costs, and preserve flight hours on frontline aircraft. A different approach appears in Gambit 4, a low observable reconnaissance design featuring a tailless layout and swept wings. Intended for operations in heavily protected zones, it combines stealth shaping with advanced sensors to slip into denied airspace, gather intelligence, and assist strike assets where survivability is critical. For naval forces, Gambit 5 adapts the concept to carrier operations. Built for launch and recovery at sea, it aligns with US Navy efforts to extend the range and flexibility of future air wings. Modular by design, it is expected to work with today's carrier fighters while preparing the ground for the next generation, helping carriers remain viable in environments threatened by long-range anti-access systems. The final member, Gambit 6, concentrates on strike missions. Marketed internationally, it merges autonomous functions and artificial intelligence with established weapons integration practices. Operating beside both crewed and uncrewed aircraft, it aims to provide affordable combat mass, a requirement gaining urgency as rivals deploy larger fleets and denser defenses. Viewed as a whole, the Gambit family illustrates a wider evolution in American and Allied airpower doctrine. Control of the skies is still fundamental but no longer guaranteed. Modern fighters, layered missile shields, and increasingly capable sensors are narrowing the advantages once enjoyed by small numbers of exquisite manned aircraft. The response is collaborative combat aviation that enhances human decision-makers instead of replacing them. In that sense, Gambit marks a turning point. Future dominance will depend less on a single superior jet than on the ability of manned and unmanned systems to function as an integrated team. Such cooperation restores mass, resilience, and flexibility without the financial and political burden of expanding pilot inventories. The deeper significance lies in the concept itself. By placing autonomous partners ahead of aircrews physically and cognitively, commanders redefine pilots as coordinators of a distributed fight rather than isolated operators. Against peer competitors, this partnership is expected to be vital for penetrating dense defenses, saturating enemy awareness, and maintaining tempo during extended campaigns. Displaying Gambit at WDS 2026 also sends a message beyond the United States. By introducing the idea in the Middle East, General Atomics signals that collaborative air combat is intended to include allies. As airspace grows more contested, nations able to link crewed and uncrewed assets into a unified structure are likely to gain a decisive edge. The vision presented in Riyadh offers an early view of how that transformation may unfold. The MQ-9B SkyGuardian is the newest development in General Atomics' Predator lineage, transforming the Reaper into a multi-domain intelligence and strike system. Built to meet NATO airworthiness requirements, it is designed to fly safely within civilian airspace, marking a significant advance for large unmanned aircraft. Endurance defines the platform. Powered by a Honeywell TPE 331 turboprop and high-efficiency long wings, the MQ-9B can remain airborne for more than 40 hours, enabling persistent surveillance over maritime regions, borders, and contested terrain. Its onboard detect and avoid suite allows operations in non-segregated airspace, while an open architecture supports a wide mix of payloads, from maritime search radars and electronic intelligence packages to electro-optical and infrared sensors. The aircraft also delivers strike capability. 9 hardpoints and a payload exceeding 2 metric tons permit the carriage of Hellfire missiles, guided bombs, and other compatible weapons. Linked by satellite control and able to fly above 12,000 meters, the MQ-9B provides partners with long-range surveillance and precision engagement across air, land, and sea. The MQ-9B SeaGuardian is the maritime member of General Atomics' new generation of unmanned aircraft designed to deliver persistent surveillance and strike power across wide ocean areas. Derived from the SkyGuardian, it pairs long endurance with mission systems adapted for naval and coastal operations. Powered by a Honeywell turboprop engine and equipped with wings spanning more than 24 meters, the aircraft can stay aloft for over 30 hours and fly above 12,000 meters, enabling broad maritime awareness while remaining clear of weather and traffic. Its defining feature is a specialized sensor package. A 360-degree multi-mode radar tracks ships at long range, supported by electro-optical and infrared cameras and an automatic identification system receiver for real-time monitoring of cooperative vessels. SeaGuardian can also perform anti-submarine warfare. By deploying sonobuoys and relaying acoustic data through satellite links, it supplements manned patrol aircraft with far greater persistence. With 9 hardpoints and a payload exceeding 2 metric tons, it can carry precision weapons against surface targets. Certified to NATO airworthiness standards and fitted with detect and avoid technology, it is built to operate safely in civilian airspace. For navies, SeaGuardian provides continuous surveillance, undersea monitoring, and strike capability in contested waters.